All right, we'll get started. Good afternoon. My name is Chris, and I'm joined by my colleague Ashok. We are from the Uber. We are from Uber, and I come from the mobile networking API teams, where we manage the Uber client APIs and the networking stack in Uber that powers all of the Uber apps to communicate with our API backends. So in this talk, we are going to be talking about some of the API migration tactics that we have employed in Uber and seen success with that. As many of you have encountered, your mobile app is typically going to have a feature which is going to make an API request with a request and getting back a response. Now, diving a little bit deeper into it, your feature is going to be wrapped around some sort of a service client. The service client is going to be wrapped inside a networking client, which is actually going to make the request and response. Your service client is where you actually talk with your business entities. This would be Retrofit or Alamo Fire. And then that converts it to a networking client, which is going to be OK HTTP NS URL, which is then going to talk to your API backend and get back your response. Going a little bit more deeper, you're going to have a cloud provider. A cloud provider is going to be a GCP or a Cloudflare, where it's going to route your request to the right gateway. Your gateway is then going to figure out what your API path is and send it to the right service. I promise you I'm not going to go into even more details, and this is the level of complexity that we will be going under. Now, the same can be analogous to a gRPC client as well, where I could say instead of a service client, I'm going to have a stub. And instead of a networking client, I'm going to have some sort of an RPC client. In this example, I'm using a gRPC client to make a gRPC request and a response back. There was a case where we had to migrate certain APIs from HTTP JSON to using gRPC, and it did require us to make that migration while we had zero impact to the business, and we wanted to hydrate these APIs while keeping the old legacy API and the new API on the fly. So the biggest motivation for us is that that particular API had to provide some business impact. It had to have a high QPS and a reasonable payload size reduction for it to convert into a HTTP format, a JSON format, into a binary format using gRPC. And the prerequisites from the team that required this migration was that we had to significantly reduce the amount of latency. The QPS to the service should not increase more than 2%. And absolutely zero downtime during this migration. So let's get into it. Typically, what you would do is create an adapter from your service client into your stub, have it pass in through your gRPC networking client, follow through the gateway, have another adapter, and then talk to your service. However, there are a lot of gotchas in between while we do this process, and that is kind of what this entire talk is going to be about. So I'll hand it over to my colleague Ashok to talk through it.
Hey folks, so I'm going to cover about different tests or different phases that we have gone through in the migration process. So I would categorize these phases into 3 different phases. So we start with pre-flight stage. At this stage, we don't have any impact on the production, but we'll just make sure our API and all other different components that got added, right, are working in tandem with each other. And then there is an in-flight. In this phase, we will slowly roll out the changes to the users. At the same time, making sure we have enough safety nets that there won't be any downtime. And post-flight, at this phase, we'll essentially just clean up all the old APIs and the old code that's on the written on the client. So now let's deep dive into each of these. For the pre-flight stage, we chose shadow calls. So what are shadow calls? So similar to a shadow, right? This doesn't have direct impact on any services, or it wouldn't create any extra computation or memory footprints on the API. At the same time, it will give you enough confidence to move forward or to get more confidence on the new stack, right? So, but before starting shadow calls, do we need to define goals that will help us to design these shadow calls? So these are some of our goals during this experiment. One, the shadow call should give us the latency benefit validation, like whether we are reducing the latency, and if so, how much we are reducing it. And also request response validation. Essentially, most of us are mobile developers, right? We know the problems that we incur in serializations, deserializations. So to make sure the new stack is on par without any problems in these stages. At the same time, it should have little to no stress on the systems, whether it's on the back end or on the mobile. It shouldn't incur extra cost. So let's look at how we designed it. So let's look at the typical request path where a mobile does call the backend service, and the request flows through network line, gateway, and to the backend service. So there are no changes here. So the request goes as is to the service. And on the way back, at the gateway is where we have this cache that caches the request of the original call, as well as the response that's transferred to the RPC call. So it would have the cache with these two items stored. But this job is done asynchronously, so there won't be any impact or latency bottlenecks on the way back. So this response is sent back to the client, and client receives it and sends it back to the feature. So the response is delivered back to the feature without any latency impact. But at the adapter layer, we also have one more job that gets scheduled to do a RPC call. So what this does is it takes the request from the old call, it transfers that into a new calls request, and it sends all the way through gRPC client, and it goes through cloud provider and back to the gateway. And from the gateway, instead of hitting the service, we hit the cache, we get back the response. This step is essentially to ensure that there is no increase in QPS to the service. But at the same time, there might be some services which are saving state on these requests, right? So we can't trigger two requests back to the service. So we get the response back. At the same time, we store the request that's happened on this path on the backend. We'll come to how we are going to use it later. Once we get the response, we send it back all the way to the mobile. And on the mobile, we convert the new response back to the old response. But haven't we already delivered the response back to the client? What are we going to do with this new response that we generate? So this is where validations come into play. So we will validate that this whole flow is working without any issues by comparing these transformed response into its equivalent response that we got from the HTTP client. And on the server side, we compare the request that we got in the first request to the new request that we have got. So essentially, by the end of this phase, what we were able to validate is this whole path that's covered in green, except for calling back to the service. We were able to validate transformers that's going to transfer your old request object into new request. At the same time, the new response object into old response format. We haven't covered the tests that were done to connect gateway to the service, because in this shadow test we don't want to increase it, but these were, there are load tests that happened on the back end to cover or test out this path. Okay, so we have validated the paths, right? So everything is working perfectly. What else do we need to validate? If you remember, one of the goals that we talked about is to make sure this reduces the latency. The reason for reduction in latency here is the old client is actually using JSON, whereas the new client is using binary formats. So let's start a clock on the mobile to calculate the latency, right? So in the old path, it will capture the latencies that were covered in all these areas: network client, cloud, gateway, as well as the service. Now, if we do the same experiment in the new path or in the shadow call, we'll be able to capture latency from gRPC, network client, cloud, API gateway. And obviously, the second one is going to win, right? Because it's not doing any extra processing. It's just getting the response back from the cache. Then how do we say that this is going to do much better in latency compared to the other one? So even at a gateway, we platformized measuring time that it's taken in the upstream. So in the gateway or in the API gateway, it calculates the time that it takes for service to respond back, whereas in gRPC gateway, we'll get the time that it takes to query the cache and get the object back. So if we remove these times from the old capture times on the mobile, now these are apples to apple comparison, right? So essentially a payload being sent from gateway and how much time is it taking through cloud, through the network client and back till the feature. At the same time, this will also, we'll be able to also capture the network payload size itself, and we'll be able to validate that. So yeah, like what are the learnings when we have done these shadow calls, right? So like the comparison is not as straightforward as we discussed before. We were talking about request comparison, right? Like request comparison between old API and new API. But if you remember the sequence, we have done the new API call a bit later than the old one, which means that many dynamic fields are going to change. What I mean by this? Let's say maybe you are sending a timestamp in a header. So the timestamp is going to differ from the old call versus new call. Let's say maybe you are sending a location. That's going to change if the user moves. So for all these dynamic fields, you need to allow a little bit of error to pop up, given these are happening at two different timestamps. But the static fields are fine. Like let's say you are sending app version, or these should be same across both the paths. And difference between cloud providers. What do I mean by this? So as we spoke, the new path is actually taking gRPC. So we are using gRPC with on top of HTTP3. It's not standardized, but there are libraries that lets us do this. So for one of the cloud providers that we use, this worked perfectly, but whereas the other one didn't support gRPC on top of HTTP3 because it's not standard yet. So we worked with the cloud provider to get that. Thank you. So, well, yeah, we fixed that bug with the new cloud provider, but this is something which we need to take care as well during the migrations. There might be some features with incompatibilities that we need to figure that out. And API behavior differences. So what I mean by this, so in the old API, we used to, let's say maybe we are using OKHTTP with retrofit. In the new API, let's say we are using gRPC. So if you are using OKHTTP, I think you will be familiar with the timeout concept, right? Like we set connection timeouts, read timeouts, and write timeouts. Let's see how those behave. So typically, whenever you do a network call, there are a lot of components that incur latency. For example, you need to acquire a thread if you're using RxJava, and you need time for serialization. If you are doing something heavy on the interceptors, there will be latency due to these interceptors. And then connection establishment, write, read, uncompression, yeah, there are a lot of latency components in a network call. When you're using OKSTTP, you can control connection, write, and read timeouts, but not the others. So what does this mean? So let's say on an API, you have set connection timeout as 30 seconds, maybe the read timeout as 20, and write timeout as 20. All add up to somewhere around 70 seconds, right? But it can still happen that you are getting the response back maybe 150 seconds later. Whereas when dealing with gRPC, it sets something called deadline. This is more like our better half, right? So they essentially quote a time. They don't care about how much time it's spent at each and every one of these steps, but overall, you just need to come back, or I am okay if you come back by 3:30 p.m. So where did we face like problems? So when we are converting that timeouts to this, it's not straightforward, right? So let's take the same example: 30 seconds of connection timeout, 20 seconds of read, and 20 seconds of write. It doesn't translate to 70 seconds of deadline. So we need to experiment on this to need to figure out what's the new deadline that we need to set. Yeah, let's look at results. Even though this is not important for the talk, we'll get back to why we are showing this at the end of the slides. So by the end of the shadow, we were able to see around 45% reduction in payload. It used to be somewhere around 160, 170 KB. It came down to somewhere around 90 KB. And the latencies dropped around 30% across different percentiles. Okay, so shadowing is done. We verified that everything in the stack is working perfectly, and at the same time, we're able to see good performance benefits. So why don't we turn on the switch, right? But yeah, it can result, the results can look bad. We don't want to cause an incident. So that's where the in-flight tasks come into play. Most of us would have used this, right? Like anytime we are trying to roll out any new feature, we do that gradually. We don't do it at single go. So we'll start with releasing out to very small % of users. We get the feedback, and based on the feedback, we'll release out to some more people. But as Chris mentioned before, the API that we are migrating is the one that's responsible for the experimentation itself. So it's a circular dependency that we all are aware of. Okay, we know there is a circular dependency. What does that mean? Like, how will that impact the users? So let's take a typical scenario, right? So let's say if I am treated, when I say treated, I mean I am supposed to go through the new flow. So I go through gRPC instead of the old stack. It goes back to the service. We get the response back. All good. Maybe in the next step, let's say we updated gRPC. It has some issues, and we are not able to properly connect to the backend, right? It's easy, so we can just roll back the feature. But given this is the API that's responsible to fetch all those flags, it won't be able to fetch these things back. So user is stuck in a state where he can't get the new API unless there is a complete app update or hotfix. It's very hard to fix this on the fly. So what we did, so we have enabled some client-side circuit breakers for this. All these are just fancy names, but small stuff. Let's look at what we have done to tackle the circular dependency, right? It's called client randomization. It's kind of a game we play like roulette. What happens here? So let's say users are treated, or if I'm treated for this session to use the new flow, but we won't listen to the backend, or we won't listen to the flag. We'll say we'll still take 50% chance. 50% of the times we send the user to the old flow, and 50% of the times we send the users to the new flow. What will this do? This essentially, let's say we still have the issue with the gRPC client, right? So now out of these 100, 50% users are still in a bad flow, bad state, but the other 50 are using the stable old flow. So they will be able to roll back properly. And on the next launch, again, these 50 will become 25, and you can see like as this gradually or exponentially moves users from bad flow to a good flow. Yeah, so we are able to fix the circular dependency problem. All are happy. But one caveat I would call in this is, even though users are treated, we are only allowing 50% of the times in the new flow. So any metrics or some, let's say, the performance metrics or health metrics that you are measuring will be 50% dialed down. So if it says your crash rate increased by 2%, it's not 2, it would be 4%. So we need to be careful here. Okay, this looks good. What else? There's a statement that says, look at the forest and also the trees. But what if we look at the forest but not the trees? What we mean by that? So again, let's understand this by a scenario, right? Let's say there is a new Android device manufacturer in the town. We are not listening to this these days, but this used to be very often, maybe 2-3 years back. But maybe they were trying something custom in the OS where they were not able to parse a new Unicode that only is applicable for some language, right? So these are very small set of users, maybe let's say hardly 20 or 25 users. They will not be able to move our metrics a lot, right? So for example, in this case, this call has somewhere around, let's say, 1,000 RPS or Oh, this is working. Thank you. So when we have around, when we have around, let's say, 1 million calls a day, out of that, if only 20 goes down, it will not even make a small dent in the metrics. So it will be very hard to look at these cases completely aggregately. So we need to have something on the device that kind of checks these things. So what we did is we built a small local rollback library. This essentially watches the flow of the API call. Whenever there is a new API call, it checks if there are more than 3 errors happen for that particular device. And again, 3 here is for our use case. It depends on what number you set here based on your use cases. And if it is more than 3, we fire an alert, because we don't just silently want to move all those users to the old API, right? At some point, we need to move to the new API. So we fire an alert on our side. At the same time, we'll use old flow for these users. If there are no errors, obviously, we'll use the new flow. And then we'll be monitoring that new flow. And whenever, again, there is an unexpected error that happens in the new flow, we increment the count, and we observe that on the next go. And also, whenever there is any major update, we reset. This is, again, a bit tied up to our use case. So we know for sure if there is any errors that we encounter, we will probably fix it in the next major app update. So we'll just reset it so that the user will come back to the new flow. And he goes through this so that we'll know whether it's fixed or not. That's cool. So we have done the pre-flight, in-flight, everything looks great. We were able to achieve the latency numbers that we planned for. At the same time, this is much more reliable. So what should we do in post-flight, like once this is done, right? Like decommissioning the older APIs. So yeah, clean up the old paths. So be a good engineer, clean up the old paths. We can get some perks from the managers. This is much easier for mobile developers. But once you remove the code, there maybe 3 weeks down the chain, there will be a backend engineer saying, hey, I'm still getting calls from the old code. Haven't you removed the paths? We all know the problem with mobiles, right? Once it's there, it's always there. Until unless user updates the app, the old apps are still going to call the old service. So how do we retire the old service then? Like, are we not going to delete the code ever on the backend? It again depends on the use cases. So you can set a budget limit. So you can say if 99.99% of the users are migrated to the new API, we might sunset the old one. Depending on the priority or the tier of the endpoint, we can set these things. Or we can follow the old method, right? Like just do a force upgrade. At some point of time, you can set a force upgrade so that all the old users will be moving to the new version of the app, and we will be able to achieve the budget limit to sunset the old code path. Okay, so let's look at results. So the shadow results that we got early versus the production results that we got now, right? Like, do you think, will there be any difference? Yeah, so for payload, I don't expect any. It's typically the same payload that we are sending in the both new like shadow flow as well as the production flow, right? We are migrating, or we are moving that to the new API response and sending it. But latency, there might be a bit, given the paths did change a bit. Like previously, we were only counting from mobile till the gateway, but right now we'll be counting from mobile till the service. So if there are any inefficiencies between that connection, those will show up here. If not, it will be close to the old ones as well. Yeah, we have gone through a lot. So let's give a quick review, right? So for pre-flight, there are different methods to check these things, and we chose shadowing with preset goals. Again, in flight, everyone does the gradual rollout, but circuit breaker with client randomization, the roll a game, or the circuit breaker with local rollback intelligence. These two, again, are specific to this use case. And post-flight, we need to do the code cleanup. At the same time, we need to remove the old API. So are these the only methods how we can test these things? No, obviously there are many more, that depending on the use case. Are these the only things that we can use on network migrations? No. If you face similar problems where it's hard to roll back a feature, right, you can use client randomization, or let's say if you, maybe if you are expecting a device manufacturer or very minute amount of users who would face some problems, you can look at like a rollback, local rollback, not necessarily just for the network clients. Hope we are done.